Hey guys, how's it going? I know it's been quite a while since the last episode, and that's entirely my fault. My bad. I have been playing a diabolical amount of Minecraft, but I'm here to continue the story. I'm looking at the footage now, and I realize that I am literally on July 2nd. So I'm gonna try and lock in and pick up the pace as I talk about what's happening. But as of right now, let's get right into it. So just a reminder as to where we left off. So I went through days 1 and 2 of the program last time. I met my lab partner on day 2. We went around exploring downtown Hefei. I was talking about a bunch of the culture shock I was receiving. But now it's going to be day 3, which is Wednesday, July 2nd. So again, it was really hard already waking up so early because I had no time to recover from my jet lag. But I wasn't going to miss these intro lectures. And I thought that these first few were right up my alley because I was there for physics. This one in particular I thought was really cool. It was about quarks and gluons. It was called When the Strongest Meet the Smallest, Quarks and Gluons in the Most Vortical Soup Under Strong Electromagnetic Fields by Professor FuSEP, I think. Good morning. It's Wednesday, and I'm already running a little bit late to a lecture. I thought it was in the same building as yesterday, but it's not. It's in a different building called the 5th Teaching Building. So I'm running around campus looking for it. I'm a bit upset too that I'm late to this one because it's cool. It's on quarks and gluons, but hopefully I'll only be a little bit late. You're gonna be seeing a lot of this, but I love this walk through campus, man. It was so green and every day was so nice. The mornings were generally fine. It got a little bit hot in the evenings. Eventually I found the building, so I went upstairs, found the room. I think there was an exam going on because as I was walking around the building, there were a bunch of bags piled outside the doors. Hopefully they did well, wishing them luck. But I went in and this one was packed. I got the last seat at the back and I got lucky because one of the organizers gave it up to me. But there were a lot of people that came in maybe like 5 minutes after me and they were just standing at the back. So I'm glad I got a seat. For this lecture, I was actually smart enough to record my thoughts after it was done. So here they are. You don't get my 1 month later opinions because I don't remember shit, I'm not gonna lie. That lecture was pretty awesome. He went over a lot of particle and nuclear physics, so one thing that he talked about was how they were making like mini universes inside of the laboratory and they were measuring some very fundamental things. They had some really funny examples for like symmetry breaking, and they were saying like there aren't enough women at USTC, so they have this matchmaking program where they pair men with women. He was using that as an example for symmetry breaking. He talked about this robot that they made in 2008, which was a combination of the top 10 most beautiful women to ever study at USTC. I thought that was pretty funny. I wonder how they came up with the metric to rank that. After that, I got some merch from the university shop. How much was it? It was 250 yuan, which is about 50 bucks. So I got a shirt, I got a hat, I got 2 fridge magnets for my mom and my sister. I think these are pretty cool. You can like shake them and then they like snow globe, but they're also a fridge magnet. And then I also got a pen and a notebook. 2 things. I think I need to start recording more of the interactions that I have with people outside, and I need to learn some common phrases for how to learn things. So I should learn to say like how do you say, so I can point to something and say how do you say this. And then I think I should also learn to say I understand or I don't understand, so that I can let people know if I understand what they're saying in Mandarin or if I don't, and then I can kind of converse through the translator app. My plan today was to grind out the vlogs, but I have to do some literature review because I have a group meeting at 3:30 p.m. So I'm gonna do that, and then I'm gonna try and edit my videos. I think I'm gonna stay inside for the next bit. I've been traveling for quite a while, but I do have a good backlog of footage that I'm sitting on. So yeah, after that, like I said, I went to the local coffee shop. I grinded for a few hours. Um, I didn't end up editing my vlog that day, as you guys know. Consistent theme. I like keep saying I'll edit my vlog, but then I just go out and explore or I nap. Um, but yeah, anyway. So after this, I went to go meet my supervisor in the lab. So it was called the CAS Key Laboratory of Quantum Information. I just finished reading some papers and editing a few photos. I'm on my way now to visit my supervisor's lab for the first time. And I'm going to be spending the rest of the day with my group. So here we go. And yeah, as I said, that was pretty much it. After this, I did spend the day in the lab, and then I also ate food with my group. They said no photos or video in the lab initially, which was pretty upsetting because it was really cool. They had a lot of cool equipment in there. They had like 32 single nanowire, single photon detectors, which is dope. Like each one of those are usually like $30,000. They had a femtosecond laser. So if you don't know, a femtosecond is 1 × 10 to the negative 15 of 1 second. So they have a laser that can shoot pulses that fast. They had nonlinear crystals. They had like more optics there than you could possibly imagine. And the lab was really, really cramped. Like it was crazy. Like you had to walk side by side to get past people in the lab. It was like a really narrow pathway all the way around. So it's like you had to walk through the lab sideways like this and shimmy your way through. Yeah, so after that we talked about projects with me and my supervisor. I picked out a project. One of my lab partners picked another project that she was quite excited about. It was pretty cool. I'll tell you guys more about that later. But then we went out for dinner. And again, I didn't want to bring my camera here because I didn't want to be disrespectful. This was like my second day. I didn't want to be holding it vlogging in front of the group. So I'll just verbally tell you what happened. We went out to this really, really nice place. Like, they drove us I can't even tell you where, but we went to like the top floor of this building where it was like just this big room and this massive table. And we sat there and we waited for the supervisor for quite a while. And me and my lab partner, we were kind of like freaking out a little bit. We were like, oh my God, like what's going on? Because I mean, you have to get the picture. It's like our third day here and we're just sitting there. And there are like a few of the students there, but they're like mingling around, talking with each other in Chinese. We're like just outsiders, I guess. But then eventually the professor comes in, Professor Shu, and we all sit around the table. So this was very stressful, I'm not gonna lie. It was like a round table. And his group had a lot of students. I think there were 15 people at the table in total, which is really big for a PhD group. So we were sitting there, and then they were bringing out food, and it was a buffet. There was like so much food. And they kept serving me beer too. Like as soon as my beer glass was empty, they like gave me another one. Like, here, take the beer. And I was like, sure, okay. And most of the time, I was just sitting there silently eating. They would ask me a few questions here and there, and I would answer. I don't really remember what they were. I think just maybe like, how is Canada? What do you think of quantum education in Canada? I remember one thing that they asked me, which I think a lot of Chinese people asked me, was they were like, what was your impression of China before coming here as a foreigner? And I mean, I would always tell them like I didn't really have that much of an impression of China, but I would say that I definitely thought that I would have to be a lot more careful than I was. Like I really thought I'd have to go there and I'd have to be like super careful about like what I say here and there. Like I shouldn't say certain things regarding like their way of life, or like shouldn't like denounce anything that they do. But honestly, I went there and it was like pretty normal. Like I felt like I could do pretty much like anything that I could do over here in Canada. The one thing though that I couldn't do was like access the internet without a VPN, which was like really annoying. But yeah, like I guess that said that there was like some Western propaganda I was influenced by before I went there. But yeah, like I just said, like I came here. It's been pretty cool. I mean, I've only been here for 2 days, so I can't really tell you what it's like until I experience more of the country. But like, I mean, like that's pretty much how it was. Like, it was literally like it felt like here, but just like more futuristic, and people actually cared about shit. But I'm not saying that there aren't issues of their own over there. Like one thing that always comes to mind is when I go and I pay for food and I pay for taxis. Like yes, it's really nice. It's 5 yuan, but that means that the drivers are making like pennies on the dollar. They make zero money. So for the layperson there, like I feel like life is really life can be really rough. And I know I was getting a lot of privilege because I was a foreigner. I mean, the way people treated me. So yeah, I mean, like I think when I've been talking about it, I've been kind of painting it as sunshine and roses. But I just want to make it clear that I understand it's not each country is going to have their own problems that come with them. But I do stand by my statement where I believe that a lot of propaganda from the West made it out to be like infinitely worse than it was. Anyway, after this dinner, like I don't think there really was much else to the day. I think I just went home and went to bed. I don't have any more footage of the day past this point, so I think we'll just start on the next day. So the next day was also jam-packed with activities, with me needing to wake up early. Good morning, it's Thursday. I'm on my way to the 9:30 lecture again, a little bit late as usual at this point. So this one is about gravitational waves, I think. I didn't really do much yesterday. I met with my supervisor, I visited the lab, we talked about the project, but I spent most of my downtime just in my room editing all the footage. There was just so much to go through. I recorded the first video. I still need to go through and edit it a little bit. So I think today and tomorrow I'm going to spend most of it just trying to grind out all of the editing. I also realize I need to be talking to the camera more as I'm outside, so I'm going to try and be doing that going forward. It makes it easier for me to edit, and also I think it makes it more enjoyable for you guys. But yeah, so this lecture is in the same building as yesterday's, so I don't need to try and find anything, which is good. I'll see you guys in the lecture. So I thought that this guy's talk was really interesting. He broke down all the different steps of the inflationary period of the Big Bang.
Our universe was created from this moment, and after that it has experienced the so-called primordial era. This was called inflation. Oh yes, it's hydrogen atom, okay? Yes, we have a lot, okay? Sorry. Well, if we have a hydrogen atom in front of us, and let's say we let this volume to be expanded by a factor of 10 to 80, it's pretty much the same size of the inner corner of a solar system. Everybody knows what's the difference between proton and the electron. They carry different charge, right? One is positive and one is negative. So you can see, well, once you have the proton and you have the electron, and if there's no special reason, then these two easily capture with each other and make a stable family. And that was how the hydrogen atom formed, right? So this was exactly what happened at this moment. And accompanied with this process, when the proton capture an electron and form the so-called the neutral hydrogen atom, then it would release one photon. And that photon evolved through the whole evolution until today. While then it is featured in the microwave band, and this was a so-called cosmic microwave background.
Now, I can't remember whether it was in this lecture or the last one, but what I found was really cool was they discovered that nuclei actually had shape to them. They actually showed that some nuclei have pear shapes, some nuclei have pill shapes, which is important when you're considering colliding them. We went to a place called Science Island, which was really mainly based around their fusion reactor that they were developing there. Okay, I'm back in my hotel room, I guess we'll call it. Back in my hotel room. I instantly crashed after the lecture. I think I didn't get good sleep last night. But we're going now to visit something called Science Island, which they have here. So the buses are boarding pretty much right away. So me and my roommate Ben are just getting ready to board. Waited in the lobby for a bit with all of the other people. And then we got on a bus. It felt like I was in like grade 4 again, going to the local farm. But instead, we were going to a nuclear fusion facility. So I want to preface this by saying that I am not a nuclear engineer. Personally, I know a lot about quantum, but I thought that I should give a little bit of a primer before we talk about the tokamak on Science Island. Like, what is a tokamak? What is fusion? What is fission? So in a nutshell, both fusion and fission are glorified steam engines. They're just a way to produce heat to heat water, which then creates energy. But that way to produce heat initially is very important. So there's this famous graph which shows basically the binding energy per nucleon. So on the y-axis is like binding energy. On the x-axis is the amount of nucleons there are. Nucleons are like protons and neutrons. So if you go right on this graph and your binding energy is going up, then that's a regime where fusion is viable. If you go left on this graph and your binding energy is going up, that's a regime where fission is viable. And this is why you break large elements for fission, such as uranium or plutonium. You combine small elements for fusion, like deuterium and tritium. And you'll notice that there's a point where there's very stable nuclei, and that peak is where like iron lives. That's part of what causes the death of stars.
Large stars can burn heavier elements, but eventually they reach iron. Iron has the highest binding energy of any element. It's the most stable nucleus. Once you reach iron, you're out of options. There are no nuclear reactions that can produce energy.
So, interestingly, actually doing fusion isn't that difficult. But what is difficult is accounting for everything, producing more energy out than you get in. One big problem is that these small elements, they're positively charged, right? Because it's a proton and a neutron. So you try and collide them, and they just kind of veer away from each other because they repel each other, because that's what like charges do. So there needs to be a way to confine these particles and accelerate them to very high speeds. And then it's also important to have the initial constituents at high temperatures. And that confining part is actually the part that's really, really difficult. And the high temperature part, well, that's why they usually have these things in a plasma state. Because the idea is that if you have some thermonuclear component of the reaction where they're already moving at a high energy just because of their temperature, then you can get more energy out than you put in, I think. So anyway, that is what the tokamak aims to achieve. It's just one of the designs that like confines this plasma to spin around in the loop. This facility we went to was one of these tokamaks, and they were telling us all about nuclear engineering. And actually on January 20th of this year, they set the record for the longest sustained I think it was the longest sustained operation of the fusion reactor. Let me just Google it to fact check myself. Okay, on physics.org, they have achieved a remarkable scientific milestone by maintaining steady state high confinement plasma operation for an impressive 1,066 seconds. Apparently, this tokamak, it's the first tokamak that has both superconducting toroidal confinement and also poloidal confinement. So yeah, they have these like superconducting coils that go around the whole reactor, and then this superconducting central piece. And this tokamak is the first one to have both of them be superconducting. What the significance of that is, I don't know. Again, I'm not a nuclear engineer. So apart from that big screen that you saw in the intro, they also had these corridors upstairs which were like explaining the reactor and the concepts on the walls as you walk through. As you can see here in this picture, this is the reaction I was talking about. So deuterium and tritium colliding to make helium and one neutron. Neutron will then go on to collide with the wall to remake one more tritium. But this corridor was super cool. Like, they had these glass panels that were inserted, and it felt like that one scene in The Hangover with Zach Galifianakis, and like all the equations are flying around his head because as you walk through there was this parallax effect. And then they also had screens all over, which just emphasized the effect that much more. Then they had this really awesome mini diorama that was in this room that was surrounded by screens on the backside, and it was basically a cross-section of the reactor, and then they had these real-time projections on the cross-section which explained how the tokamak worked step by step. And this thing was really fancy. Like, they had stuff inside of it, they were projecting things onto it, and then they also had lasers that were pointing automatically at specific things as the description of what was going on was happening in the background. So yeah, we walked through, there were more screens, more descriptions, more cross sections. Here's one that describes the anatomy of the tokamak far better than I can. Then they started talking about the development of the project, how it reached different milestones over time. Then of course, more screens. They had a wall which was showing basically all the awards that their project had achieved. It was a very full wall. They had a few more cool dioramas. These were more explaining the area that it was in, so the layout of Science Island, where all the buildings were located, the fusion energy test reactor. Honestly, like, more fusion propaganda, like, oh, it's ultimate energy source. I mean, obviously fusion is the end goal. It's phenomenal, but like, it was very over the top, I would say, but it was entertaining. So then they had us take a picture for the program, and then we went outside to another building, which was, this place was like a garage outside.
I
So hot outside. And in here they were, again, just telling us more about the tokamak. This one was more focused on the construction of it. So over here, this is pretty cool. They said that this is the strongest 5-axis robot arm in the world. This blue one that you're looking at right now. You can actually hear him say it here. I caught it in the clip.
This is the most powerful and the strongest robotic arm in the history.
They then had a cross section of the tokamak that you could actually climb into for scale. So this was pretty neat. Me and Ben climbed in. We looked around. We got there before most of the other people went in, so it was good because it wasn't too crowded inside. We actually, I say we could look around, but the space itself was pretty small. They had a whole bunch of random other stuff in here too, which I thought was pretty cool. I had no clue what these robot arms are for, but they had like a camera on them. They kind of reminded me of the Chappie robot. I thought they were kind of cute. And then just machines. Looked very high tech though. But the tokamak was huge. I took a picture for my Instagram. Here's what it looked like from the side. For some reason, I'm missing footage after this point. I'm guessing my camera battery died or I ran out of storage or something. But the next bit is at the end of the day, me and Ben decided to go get some KFC, as you do when you're in China. Ben and I are headed to the KFC. We just came back from the Science Island tour, and we are like absolutely famished.
For context, I didn't have breakfast or lunch.
I just didn't have lunch, but I'm still gonna complain. Like, I'm starving. So we're thinking about what to try. There is both a Burger King and a KFC, like right here. There's the Burger King. There's the KFC. I also like how the walking sign has like a little animation to it. So we ordered 2 sets of 8 wings, and we got ice cream coffee, which was pretty neat. The total came out to 60 yuan, which is like $12 Canadian, which is pretty neat. They also have something here called K-Coffee.
Hello, your food is ready.
Oh, thank you.
Oh, dude.
That looks so good.
No, the smell of it is just.
Yeah, eat the chicken with the gloves.
Criticized it.
Look how small the chicken pieces are. It's really good though.
The coffee is really good too.
While we were there, I saw this car outside, which was pretty cool. It had these LEDs on the front bumper, and they had this custom animation that was playing on it. I'd never seen anything like that. But yeah, so that was the end of the day with Science Island. I think I am going to end the vlog here. We'll pick up again, as usual, the next day. Sorry for such a long wait between the last 2 vlogs. I'm really going to try and get on it this next week to pump out more content. So stay tuned, and I will see you guys in the next one. Bye.